In the vast Pacific Ocean, a monstrous behemoth has stirred, terrifying scientists and sending shockwaves throughout the globe. Hunga Tonga Hunga Ha'apai, an immense underwater volcano near Tonga, has finally erupted, with an explosive power equal to 100 Hiroshima bombs. For years, scientists dreaded its awakening, fearing the havoc it could wreak. Now, their worst nightmares have materialized. The largest underwater volcano has finally woken up, and something unimaginable is happening. What's happening? What could have triggered this colossal fury? And has been requested by some of you folks in the comments, what are the long-term consequences of this eruption on our climate? Get ready for a revelation unlike any you've heard before. Volcanoes, those majestic yet threatening geological features, may appear to be remnants of a distant past, especially considering the infrequency of major eruptions in modern times. However, this perception was brutally shattered by the recent cataclysmic event at the Hunga Tonga Hunga Ha'apai underwater volcano. The eruption at Hunga Tonga Hunga Ha'apai etched its name in the annals of geological history by becoming the most potent atmospheric explosion ever documented. Its aftermath was nothing short of terrifying, triggering an astonishing 11-hour supercharged thunderstorm that sprawled across a vast area, spanning approximately 150 miles, which is about 240 kilometers. Not just that, the eruption produced a high eruption column, reaching elevations of 57 kilometers and thus reaching into the mesosphere, which is now raising concerns about the terrifying climatic and atmospheric impact this will have on our planet, Earth. Before delving deeper into the terrifying details of this eruption, it's crucial to grasp the historical context surrounding the Hunga Tonga Hunga Ha'apai volcanic system. Nestled in the vast expanse of the Pacific Ocean, within the Kingdom of Tonga, this volcanic entity is part of the larger Tonga Chromatic volcanic arc. This region is renowned for its seismic activity, arising from the convergence of the Pacific Plate beneath the Indo-Australian Plate. This geological convergence has led to a chain of islands and volcanoes, many of which exist beneath the ocean's surface. Hunga Tonga Hunga Ha'apai stands as a testament to this natural spectacle, with only two small volcanic islands, Hunga Tonga and Hunga Ha'apai, breaking the waterline, and serving as silent markers of the submerged volcanic activity below. These islands stand as remnants of the once imposing caldera's northern and western boundaries. The sheer magnitude of this submerged giant is staggering. Its base sprawls across a considerable 20 kilometers in diameter on the seafloor. From this expansive foundation, the volcano rises majestically, ascending to a height of approximately 2,000 meters toward the ocean's surface. For decades, the volcano's caldera lay beneath the sea, approximately 490 feet below sea level, measuring 2.5 miles in length and a mile in width, a truly massive expanse. The landscape of this caldera, shaped by deposits from previous volcanic eruptions, constantly evolves, leaving behind evidence of eruptions dating back to the year 1108 CE. Historically, these volcanic islands have experienced periodic eruptions. The first recorded eruption at this site occurred in 1912, followed by a significant eruption in 1937. This volcano has also erupted a few times over the 21st century. In March 2009, a submarine eruption near the Hunga Tonga Hunga Ha'apai spewed steam, smoke, pumice, and ash thousands of feet into the sky. This eruption, observed by Tonga's chief geologist Kalipi Mafi, created a new land surface between two vents, practically devastating Hunga Harbour Island and blanketing it in a thick layer of black ash, obliterating all vegetation and fauna. The volcano stirred once more in 2014, as volcanic plumes and a series of earthquakes rattled the volcanoes north of Tonga for several weeks, signaling a resumption of volcanic activity in the area. In mid-December 2014, a new eruption began, marked by a tall white steam plume rising from the ocean over the volcanic mount, visible to local fishermen. Satellite imagery confirmed the eruption's continuation, with a smoke and ash plume rising from the site. The eruption persisted into 2015, with a towering ash cloud reaching 3 kilometers into the sky. A new phase commenced 10 days into January, characterized by ash plumes soaring as high as 9 kilometers. Geologists from New Zealand and Tonga, upon their visit, observed the eruption's decline. Most of the activity was concentrated in the vent on the new island, with limited ash emissions and magma rocks hitting the ocean, leading to steam explosions. No floating volcanic debris was discovered by the team. By the end of January, Tongan officials declared the eruption had ceased, marking the end of this chapter in the volatile history of Hunga Tonga Hunga Ha'apai. In June 2017, two French explorers, Cecil Sable and Damien Gruya, made their way to New Island aboard their sailing boat. During their visit, they snapped photographs of the island's landscape and gathered a total of 16 rock samples. These samples, seemingly insignificant at the time, gained immense importance when they fell into the hands of scientists at NASA's Goddard Space Flight Center. To their surprise, these rocks from Hunga Tonga Hunga Ha'apai became a crucial model, helping researchers understand the peculiar volcanic shapes that grace the Martian landscape. A deeper analysis of these samples revealed a fascinating tale. The volcanic ash, a significant component of Hunga Tonga Hunga Ha'apai, had a unique interaction with the warm oceanic waters surrounding the island. This chemical reaction transformed the ash into a robust rock, suggesting that the island could endure for several decades. It was a revelation that hinted at the island's stability and longevity, painting a picture of resilience against the forces of nature. However, an unexpected twist of events occurred with an eruption in 2022. The eruption of Hunga Tonga Hunga Ha'apai in 2022 commenced in December 2021, with the volcano spewing forth a massive plume that was visible even from Tonga's capital. The eruption's force was so formidable that it generated audible sounds all the way in Alaska, over 6,000 miles away. Over the course of about 4 weeks, the eruption reached a crescendo of immense power. Experts assigned a volcanic explosivity index, VEI, rating of at least VEI 5 to this eruption, describing it as akin to a magma hammer. At its peak, the volcano unleashed a sequence of 4 underwater thrusts, displacing an astonishing 10 cubic kilometers of rock, ash, and sediment. This eruption etched its name in the record books as the largest atmospheric explosion ever recorded with modern instruments. The explosion's shockwaves reverberated across the globe, marking a remarkable feat in volcanic activity. The colossal explosion of Hunga Tonga Hunga Ha'apai also triggered devastating tsunamis that rippled across vast distances, wreaking havoc in several nations along the Pacific Rim. Tonga, Fiji, American Samoa, and Vanuatu experienced the brunt of the impact. However, the tsunamis also lashed out at distant shores, causing significant destruction in New Zealand, Japan, the United States, Chile, Peru, and the Russian Far East. The aftermath of this natural disaster was marked by tragedy. In Tonga, the tsunami waves reached staggering heights, up to 20 meters. The result was a staggering loss of life, with around 4 individuals losing their lives. Many more were severely injured, and a grim possibility lingered as some people remained missing in the aftermath of the disaster. The force of the waves left communities shattered and struggling to cope with the scale of the destruction. Peru, too, felt the impact, albeit on a smaller scale. The 2-meter-high waves that crashed into the coast claimed the lives of 2 individuals, marking a tragic reminder of the tsunami's power. The eruption of the Hunga Tonga Hunga Ha'apai volcano, although significant, found its match in history with the catastrophic Krakatoa eruption of 1883. Krakatoa, nestled in the Sunda Strait between Java and Sumatra in Indonesia, wreaked havoc from May 20 to October 21, 1883. Its explosive fury spewed an astonishing 5 cubic miles of rock fragments and immense quantities of ash, blanketing an area spanning 300,000 square miles. This cataclysmic event claimed the lives of over 36,000 people and resonated as far as Perth in Western Australia and the island of Rodrigues near Mauritius, both approximately 3,000 kilometers away from Krakatoa. Its impact echoed through history as one of the deadliest volcanic eruptions ever recorded. Comparatively, the Hunga Tonga Hunga Ha'apai eruption, described by NASA as 100 times more powerful than the atomic bomb dropped on Hiroshima, was a staggering event in its own right. Recent scientific findings have shed light on the extent of its power. Seafloor surveys revealed that the explosion excavated a colossal 2.3 cubic miles of rock. Even more astonishing was the eruption's reach, It propelled a plume of scorching gas and ash approximately 35.4 miles into the sky, surpassing any observed phenomenon of its kind. Additionally, the eruption injected an unprecedented 146 teragrams of vaporized water into the atmosphere, a quantity capable of significantly impacting the global climate. The eruption's impact was not confined to its immediate vicinity. The resulting tsunami traveled across oceans, leaving scientists astounded at its far-reaching effects. Satellite images vividly captured the ferocity of the explosion, showcasing shockwaves radiating through the clouds surrounding the expanding plume. Marine geologist Kevin McKay, deeply immersed in the study of this event, emphasized its enormity, stating, "It was a massive event. The more we study it, the bigger the event becomes." For the nations along the Pacific Ring of Fire, including Tonga, this eruption served as a stark reminder of their vulnerability to nature's whims. The Deputy Secretary for Natural Resources in Tonga acknowledged the incident as a lesson, emphasizing the perpetual need to explore and understand the profound forces that shape our planet. But, what triggered the immense fury of the Hunga Tonga Hunga Ha'apai eruption? In order to gain insight into the mystery behind the immense eruption of Hunga Tonga Hunga Ha'apai, scientists launched a comprehensive investigation. This endeavor, named the Tonga Eruption Seabed Mapping Project, was a joint effort between NIWA and the Nippon Foundation. The researchers meticulously explored the region, mapping the seafloor, capturing images, and collecting samples of volcanic rock and ash. Their extensive study covered approximately 8,500 square miles surrounding the volcano. What they discovered painted a vivid picture of destruction. The key culprit behind the devastation was identified as a pyroclastic flow, a deadly avalanche of searing hot ash and volcanic debris that moves with terrifying speed, reaching up to 200 meters per second. These pyroclastic flows, incredibly hot and capable of burning everything in their path, form when the volcanic material expelled during an eruption cascades down the volcano's sides. While scientists have detailed knowledge about pyroclastic flows on land, the underwater dynamics remain somewhat speculative, as none have been observed firsthand. The researchers hypothesized that as the debris plummeted into the sea, the scalding ash likely vaporized the water, creating a gas layer that propelled the material across the ocean floor like a slippery slide. Evidence of multiple pyroclastic flows radiating around the caldera's rim was found, cascading over rises and into valleys. These flows severed domestic and international communication lines, impeding Tonga's recovery efforts. Emily Lane of NIWA conducted modeling that explained how the volcanic material interacted with the underwater landscape. The eruption, which dug down 2,300 feet into the central crater, flung 3/4 of the excavated rock within 12 miles of the volcano. The remaining material circulated in the atmosphere as dust, intensifying the colors of sunrises and sunsets in the following months. While the eruption has temporarily quieted, Hunga Tonga Hunga Ha'apai remains restless. It continues to release hot water filled with volcanic glass fragments, indicating that it has not returned to dormancy. Alarming findings suggest that due to the 2022 eruption, the risk of this colossal underwater volcano erupting suddenly has surged by a staggering 360%. This heightened risk is deeply concerning due to the vast impact such eruptions can have. Beyond the immediate devastation, they lead to secondary disasters like tsunamis and climate effects, making them even more threatening. A study led by Oxford University scientists delved into the aftermath of the January 2022 eruption. Their research unveiled a shocking fact: it created the tallest volcanic plume ever recorded, reaching an astonishing height of 57 kilometers. To put this into perspective, it reached the mesosphere, a part of Earth's atmosphere typically associated with phenomena like shooting stars. This was a significant leap from the previous record set by the 1991 Mount Pinatubo eruption in the Philippines, which had a plume reaching 40 kilometers high. Japan's Himawari 8 satellite captured images of this unprecedented event, allowing scientists to study it closely. The mesosphere, where this eruption occurred, lies between 48 and 80 kilometers high in the atmosphere and is notably the coldest part of Earth's air layers. Dr. Proud, a researcher, emphasized the uniqueness of this eruption because it introduced a considerable amount of water into this usually dry part of the atmosphere. This unexpected event provides scientists with a valuable opportunity to test climate and weather models against extreme conditions, helping us better understand and predict such events in the future. Meanwhile, to comprehend the long-term impact of the recent underwater volcanic eruption on the climate, it's essential to first grasp the connection between volcanic activity and weather patterns. Volcanic eruptions have a significant impact on Earth's climate and weather patterns. When they erupt, they release gases and particles such as sulfur dioxide, carbon dioxide, and ash into the atmosphere. The conversion of sulfur dioxide to sulfuric acid has a substantial effect on the climate. During major explosive eruptions, vast amounts of volcanic gas, aerosol droplets, and ash are injected into the stratosphere. These aerosols reflect sunlight back into space, cooling the Earth's lower atmosphere. Some eruptions in the past century caused a temporary decline in the Earth's surface temperature by up to 0.5 degrees Fahrenheit for periods of 1 to 3 years. Traditionally, volcanic eruptions have tended to temporarily cool the Earth. Sulfur.